Okay, finals review take two. Solving for the x variable. X plus 3.1 equals negative 6.7. So the equal sign's right there. So x is over here. You got plus 3.1, so the opposite of plus would be minus 3.1, and then minus 3.1. So I have x all by itself, nothing happening to it anymore. And then I take negative 6.7 and minus 3.1. That's going to be negative 9.8. The 6.7 was negative, so. Okay, number two. There's x. Now between the x and the negative 2, there's no sign. That means it's being multiplied. The opposite of times is to divide, so we underline both sides. And negative 2 is the number we take underneath because that's a multiplier of the x. So line up your equals and you have x. 26 divided by negative 2 is negative 13. Okay, number 3. So here's x. You got two things happening. You have a times 3 and you got a plus 8. So we have to deal with the plus 8 first. So the opposite of plus 8 would be minus 8. So we minus 8, minus 8. So line your equals up. You have 3 times x. And negative 7 minus 8 would be negative 15. And then x is still being times by 3, so the opposite of times 3 is to divide by 3. And I now have x all by itself. Negative 15 divided by 3 is negative 5. So negative 5 is our solution. Okay, 4, I want you to make a little change here. I probably would alert you to this. If I put this problem on a test, I'll tell you kind of what to do with it before it starts. But it's kind of a weird problem because you have times 10 because there's nothing between it, and then between the 25 and that you have a minus. But any time that x is multiplied and that number has a subtraction sign in front of it, you want to make it plus and then right after make your 10 negative. So now it's just plus 25. So we have to deal with the plus 25 first. Okay, so the opposite of plus 25 would be minus 25. That's 0 on that side. On the other side we have 30. We have negative 10 times x, okay? And then x is still being times by negative 10, so I need to divide by negative 10. So we have x by itself now. 30 divided by negative 20 is negative 3. So again, you had x times by a number. If that number that it's like up here that had a plus in front of it, so I didn't do anything with it. When the number that x is being times by has a minus in front of it, you really want to make that plus and then that negative. Cross out these two on the bottom, number 7 and number 8. I don't need you worrying about those. Okay. Number 5, solving for x. Now if you look at this one, a little more complicated. Okay, negative 4x minus 5 plus 2x equals 10. Now there's two different x variables in the problem, right here and right here. Now the question becomes whether they're on the same side or whether they're on opposite sides. Well, here's my equals, and they're on the same side. So we make the adding v. Okay, so equals, and then you got 10 all by itself. And then when I'm adding, I add negative 4 plus 2. So negative, because it's negative 4x plus 2x, but I got to figure out what negative 4 plus 2 is. It's negative 2. So negative 2, remember to put the x on that. And then you still have minus constant of 5. Constant means it's not multiplied by a variable. There's no variable behind, there's no letter behind the 5. Okay, now it's a much easier equation for me to deal with. I have two things happening to x. We have times negative 2 and we have minus 5. So I deal with the plus or minus first. So I need to do the opposite, which is add 5. And 10 plus 5 is 15. And over here I've still got negative 2 times x. Negative 2 times x equals 15. Now I got to solve for x. So the opposite of times is to divide by -2. So I have x. And 15 divided by -2 happens to be a decimal, which is okay. -7.5. Okay, number 6. Again, we have that kind of the same problem we had up here. There's two different x's, but this time instead of being on the same side like they are up here, they're on opposite sides. So I'm going to mark out the smaller of the two. And I need to get rid of that 3x by either adding, I need to get the 3x to a 0. Okay, so if I'm at 3 and need to get to 0, I would subtract 3x. And then I subtract 3x from the 5x. So I have -7 now. That's going to be 2x plus 19. Now, again, it becomes much simpler. So again, make the v if they're on the same side. If they're on opposite sides, mark one of the two. It really doesn't matter. I usually do the smaller one, and then you think, how could I get that to 0? Would I add or subtract? Okay. Well, it's +3, so you'd have to subtract to get it to 0. Okay, now x is still, we got ×2 and plus 19. We do the opposite of plus 19 first, which is -19. Line your equals up. And then -7 minus 19 gives me -26. Over here you got 2 times x still. Okay, then we divide by the factor of 2. And then x will be by itself on one side. So -26 divided by 2 is -13. Okay, number 9. X divided by 4 plus 9 equals -6. So here's the x, okay? It's only on, I only have this single x right here. Now it's being divided by 4, and then there's a plus 9. So we deal with the plus 9 first, so -9. So we got x divided by 4, and then -6 minus 9 is -15. Now, what's happening to x? It's not being multiplied, it's being divided. So the opposite of divide is to times. So we make a dot on each side, and after the dot on each side, we put that 4, because that then allows me to can't cross the 4's out. I have x, -15 times 4 is -60. Okay, number 10, 1/2 x plus 4 equals -7. Now again, you got two different things happening on the x side of the equation. You have multiplied by 1/2 and you got plus 4. So we do the opposite of plus 4, it's going to be -4. So 1/2 times x. Make sure you pay attention that the 7's negative, so it's not set, don't put 3 down. -7 minus 4 is going to be -11. Okay, now I have multiplication, but remember, when I have multiplication by a fraction, I actually do it times, and I flip the fraction. So 2 over 1, because then I can do that, and over here will be 2 over 1 as well. So x is by itself. Now we're going to figure this out. I would put a 1 under the 11, and then -11 times 2 is -22. And then 1 times 1 is 1. Then divide those two, it's just -22. So again, when you have a fraction multiplier, you flip the fraction and multiply it. Okay. Okay, story problems. Now keep your eye on that table up there. It says an internet repair service charges $75 for diagnosis. Diagnosis means they come in and tell you why it's not working. That's all they do. But then they charge for $30 per hour for repair. They charge $30 per hour to fix it. So before they even will work on it, it costs $75 just to come in and tell you what's wrong with it. If the total bill was $150, how many hours did the repair take? Now if you look up here, your X, the hours start at 0, but before they pay $30 per hour, they had to pay $75. So it starts at $75. The cost does. The cost starts at $75. The Y unit, the Y variable costs at $75. So I'm going to want to make my 3 boxes with the line. Okay, starting with that 75 right there. There are some other problems which we're going to get to in the other packet where if x is 0, y is 0, but this is not one of those problems. You start with 75. Okay, now my units are dollars and hours. Remember, the time unit is always x. Hours would be x, and money would be y. X can never be money. So per, and then we put the y unit above it and the x unit, dollars per hour. So after they pay $75, they pay $30 per hour, so 30x, and that's your what's called your slope. You probably heard that at your old school slope, 30x. Means every time I go up by 1 hour, I'm going to take that up by 30, 30 over 1 or 30. Now we'd add those and then equals my y variable. So I write that equation out, 75 plus 30x equals y. Now I need to figure out how many hours this took, so I'm solving for the x. That means I got to put a number in for the y, and the number I put in is $150 because y is money and the total money is $150. And now I can solve for x. We have a times 30 and a plus 75, so I do the opposite of plus 75 first. That takes that to 0. I've still got 30 times x, and then 150 minus 75 is 75. And I divide both sides of the equation by 30, because the opposite of times is divide, of course. 75 divided by 30 is going to be 2.5. So hours is 2.5. Okay, number 12, I need to get a new air conditioner. There are two services in town from which to choose. Service A has a charge of $3,000 for installation plus $200. That means it's $3,000 for the air conditioner, okay, plus $200 to the workers for labor per hour. Service B has a charge of $4,000 plus $100 per hour for labor. How many hours of labor will the cost of the services be equal? Okay, now again, at 0 hours, you had to pay $3,000. That's before the hours kick in. So again, these y values actually have a beginning number, so we're going to go with our 3 boxes. But I will need 2 lines because there's 2 tables. This one would start at 3,000 and the other one starts at 4,000. So this one starts off higher, but they would eventually catch up. And you'll see why here in a second. So I've got dollars and hours. Time is x, dollars is y. So per dollars per hour. Now there has to be $2 per hour rates, and there are 200x times the hours. And this would be 100x. Okay, so 200 is with the 3,000, 200x, and then 100x. And then plus and plus, then equals y and equals y. Or actually, no, on 2 lines, don't even put y. You don't need it, okay? So this one starts off more than this one, but this one's adding 200 every step. This one's adding 100. So eventually, this one catches up to this one. I got to find out when, after how many hours. So my equals, on one side I do 3,000 plus 200x. Now on the other side I go 4,000 plus 100x. Now you got x's on opposite sides, so they're on opposite sides, so mark the smaller one with an arrow. We'll go with the 100. We got to get that to a 0. It's positive 100, so we would want to subtract it so it goes away completely. Then I come and subtract it from 200. So over here we got 4,000. Now over here I would do the 200 minus 100 first if I were doing it. That would be 100x. Don't forget to put the x on the 100. And then we add the 3,000. And now it's a simpler equation. You got times 100 and plus 3,000. We have to do the opposite of plus 3,000 first, which is to minus 3,000. So I have 100x, and then 4,000 minus 3,000 is 1,000. Okay, so x is being times by 100, so you do the opposite and divide. 1,000 divided by 100 is 10. So the hours is 10. That's after how many hours they would be equal. It's probably not going to take them 10 hours, so you'd probably, if you were deciding between the two, you'd want to pick the one with the 3,000, where the furnace is cheaper. Okay, I'm going to sharpen my pencil quick because it's dying, because I don't have a pen. And then we'll get on to the ratios and proportions. Okay. Solve the proportion, and got pretty good at that as we went along. So again, I line up an equation. 3 times x is 3x. 7 times 9 is 63. The only thing that's happening to x is a times 3, so we divide by, and it broke. That's awesome, man. So I divide both sides by 3, and 63 divided by 3 is 21. Okay, next one is a little more complicated proportion. I circle where there's 2 different x's. So I have 5, but I got to take it times 7x and times 4. You got to take 5 times both of them separately. So that's going to be 35x, and that's going to be 20. So on that side of the equation, we're going to have 35x plus 20. Now, on the other side, I got to take the 3 times both the 2x and the negative 3 right there. So 3 times 2x. If that has a minus in front of it, multiply it as a negative. Okay. Again, there's my multiplying number 3. I wrote it down twice. I'll be taking it times 2x and then by negative 3. So that's 6x and negative 9. So that would be 6x minus 9. Okay, and away I go. Now, you got x's on opposite sides, so don't make the v. Mark out the smaller one. Get that 6x out of there entirely. If it's positive, we would have to subtract it. Then from 35x, so 35x minus 6x is 29x, and then plus 20 equals negative 9. Okay, so we got plus 20 and times 29. We do the plus 20, so minus 20. Negative 9 minus 20 is negative 29. I got 29 times x, and then I divide by the 29. That ends up being negative 1. A number divided by itself is 1. If it's a negative divided by a positive, it'd be negative 1. Okay, percent proportions. What percent of 20 is 35? I'll not draw them so big. I've got the percent to 100%, and then the is and the of. So I don't have, neither one of these are percents, so it's x percent, and then of, after of we got 20, and then is 35. So the percent's going to be higher than 100 here. Okay, and it's pretty easy. You take x times 20, that's just 20x, and then 100 times 35 is 3,500. Now the only thing that happens to x is it times 20, so we divide by 20. I don't know what that is. So 3,500 divided by 20 is 175. Now since the x is with the percent, we want to label it with a percent symbol. Okay, what's 20% of 3? Probably not very much. 3 is not a big number, and we're taking 20% of it. So percent, we got 20. And then after of, we have 3, and then I don't know the x. So 100 times x is written as 100x, and then 20 times 3 is 60. And then the opposite of times 100 would be divide by 100. So 60 divided by 100 is 0.6. Now some people will be like, is that right? Well, yeah, it is, because 3 itself is a small number, and if we're taking the 20% out of 3, it's going to be even tinier than 3. 60% of what number is 34? Okay, so my percent is 60. Got that. After of, it says the word what, so there's my x, and then 34. Okay, so 60 times x is written as 60x, and then 100 times 34 is 3,400. Now the only thing, again, you just need to divide by 60 now. So 3,400 divided by 60 gives me 56.6 repeating. Just go 57. Okay. Number 6, similar triangles. I screwed, this should be a 12 here. Okay, not a 2. That doesn't make any sense if that's 2 and that's 4. That's idiotic for me to do. Okay, so I'm solving for x. Well, on that same triangle, I have 12, so I put x over 12. Now, what side is... Oh, holy cow, is this problem screwed up. Put a 6 there. So, similar to the x, you have 6, okay? And then 4. Okay, and away we go. So, x times 4 is 4x. Equals, and then 12 times 6 is 72, and now I can go ahead and divide. 72 divided by 4 is 18. Okay, convert 6.5 feet to inches. There's 12 inches to a foot. You want to, again, use proportions. So 12 inches with 1 foot, that's on the same proportion. Okay, and over here I have 6.5 feet, so I have the feet, I don't have the inches, because we have to get to the inches. So 1 times x is 1x, and then 12 times 6.5 is 78. Okay, now, you can divide by 1 if you want, it's still going to be 78. So 78 inches. Okay, now some word problems. 3 pounds of cookie dough makes 96 cookies. If Eric is planning to bake 305 cookies, how many pounds of cookie dough should be made? So there's an XY table, and I had the X be cookies, the Y be pounds. It really wouldn't matter because there's no time unit and no money unit, but that's just what I picked. But if you look at the original table, when X is 0, the Y is also 0. Because if you're not going to make any cookies, then you don't need any pounds of cookie dough. So I'm not going to make those boxes with the line because there'd be nothing to put at the beginning of the line because there's nothing. It's 0. So that means I go into my proportions. They're proportional. And you got cookies and pounds. It doesn't matter what. If there's no time unit, it doesn't matter what goes on top or bottom. Cookies and pounds, cookies and pounds. So I know we got 96 cookies, and it takes 3 pounds of cookie dough. And I have 305 cookies. I want to know how many pounds of cookie dough. So 96 times x is written as 96x, and then 3 times 305 is 915. Okay, then we can just go ahead and divide by 96. So 915 divided by 96 gives me, just put 9.5. So you can have a decimal for pounds if you're measuring the weight. Measurements can always have decimals. Number 9, I can paint one wall in 3 hours. My friend can paint one wall in 4 hours. How long will it take us to paint 4 walls in a room if we work together? Now we got me and my friend, okay? So there's 2 different people. But 0 hours, he'd get 0 walls painted, and the same with that one. So since both of these, there's no beginning amount. If you made lines, it'd be a waste because there's nothing to put at the beginning before the hours go in, okay? See, on that other packet, that first packet, you had a 0 and then a 75, so you would make a line with the 75. Here it's 0 and 0. So again, that's proportions, but with two tables, because two different people, we need to add another ratio into the proportion. That's a plus. That's a plus. A lot of people put times. It's plus. Now again, you do have time units. You want to put the time unit on the bottom, the hours. And then the other unit, the walls, would go on top. So the ratio for our first person, you can do 1 wall, 3 hours. For our second person, you can do 1 wall in 4 hours. Okay, now together we have to do 4 walls, and I don't know how many hours it's going to take, so it's X. So I need to simplify this by adding these two. Okay, so it's 4 over X, and then walls and hours. 1/3 plus a 4th, common denominator and all that is done on the calculator, so that's 1/12, or 7/12, my bad, 7/12. That's walls and hours. So if they work together, they can get 7 walls in 12 hours. That's her ratio, simplest together. They need to do 4 walls, X hours. So 7 times X is 7X. And then 12 times 4 is 48. And then just got times 7, so divide by 7. And 48 divided by 7, you can go ahead and put 7 if you want, okay? So 7 hours, that said hours there. Okay, this should say, scribble that out, that should say part, okay? 3/4 of the company's total money is spent on production. If $15,000 is spent on production, how much total money does the company have? Now, any fraction word problem, we want to make our proportions 3 out of 4. Now, label the 3/4. The 3 represents what I've circled, okay? Spent on production. And this is my total. And then over here, the labels need to match. Spent on production and total. Now, about that 15,000, does it say that's spent on production? Yeah. It does, so 15,000 goes here. Now I'm trying to figure out the total. When I figure out how much total money the company has, that's me figuring out the total. Okay, so 3 times X is written as 3X, and then 4 times 15,000 is 60. This times this is 60,000. And then you got times 3, so we divide by 3. That's 20,000. So the company has $20,000. Okay, number 11. I gotta sharpen my pencil, it's dead. Hopefully that's the last time for that. Okay, number 11. 18% of Florida's land is covered by water. If water covers 11,800 square miles, what's Florida's total area? So again, a percent, so you put 18% to 100%. And those have labels. It's covered by water. And 100's always your total. And up here, covered by water, and that's the total. Okay, 11,008. Okay, it says that's covered by water, so we put it up here. X here. I guess it's kind of the same as the last one. So you got 18 times X, 18X. 100 times 11,800 is going to be just write that number down. It's 1,180,000. And all you have to do is divide then. Now you don't need the decimal, just go 65,555 or 556, it doesn't matter. You can put 55 or 56 at the end there. And the label would be square miles, the same as this label. 18% is covered by water, that much is covered by water, so there'd have to be that much total. Okay, at the beginning of football season, Charles could bench press 275 pounds. After football, his bench press had increased by 20%. What is his bench press after football? So again, a percent. Now it says 20, but we don't want to put 20. Increase means we need to add 100% plus 20%. That'd be 120%. Now when I have to add or subtract a percent from 100, the labels then become after for the top and before on the bottom. Okay, I want to know his bench press after football. That's why that's circled. So X, and then before it was 275. Okay. So 100 times X is 100X, and then 120 times 275. 33,000. Then we divide by 100. That's going to be 330. And then if that's pounds, then this is also pounds. Okay, number 13, last one. Cross, you don't need these two. I don't know why I wrote. Those are true, but you don't use them for this problem. Two cars travel for the same amount of time. The first car travels at a speed of 49 miles per hour, while the other car travels at an average speed of 60 miles per hour. If one car travels, switch that 45 to a 44, just because I said so. If one car travels 44 miles further than the other car, what distance did each car travel? So we're going to set up our table. And we got fast and slow. Distance, speed, time table. So you got the speed, the distance, and the time. Remember, speed is your miles per hour. Distance is just your miles without the per hour. And then time is the hours. Okay, so my speed, we got 49 and 60. So 60 is fast, 49 is slow. Now the miles driven, it says one car travels 44 miles further than the other car, so we don't know the miles they traveled. So they both start off as X's, but I'm allowed to add those 44 miles to the faster car. And then the hours, I have no idea. I just know they were equal. So I use my distance divided by speed. So the distance here is the expression X plus 44, and the speed is 60. The distance is X, the speed's 49. Set those equal to each other, and you can solve. Okay, now so we know 60 times X is 60X. That product's pretty easy, but over here, you got to take 49 times X and 49 times 44, so I'll put a 1 there. You don't have to put the 1, you just times it by X, it'd be the same thing. So we know that that's 49X, 49 times 44, probably going to need a calculator. 2,156. Okay, so we got 49X plus 2,156. Okay, I got X's on opposite sides of the equation, so we'll mark that one and get that to become a 0 by subtracting it. It's like you're making. So that's 11X, and over here you got 2,156. Then I'm just dividing by 11. I got 196, okay? So So that is your first answer. So you got 196 miles here. Now to find the other one, you just take 196 and add 44. Okay, 240. Bada bing, bada boom.